What do you have to do? Be careful about here.
Include the 0x squared.
Yeah, there's no x squares.
4x.
Where is it? 4x minus 1. Okay. Some of you guys are staring at me. I'm guessing you went through this really quick. So you guys don't even have paper out. You're like, just do it now, boy. All right. So how do I start this off?
X.
What times what?
Yeah, x squared times what is x cubed? Exactly what we would do with long division of numbers. It's exactly what we would do. So what is it?
X.
Holy shit. So x times x squared, x cubed. X times negative 3x, negative 3x squared. X times 2. And then I
Switch the sign.
change the signs. Change, change, change. Shabam. Why did I do that? Because that's how we do it. That's how you do long division. Yeah. So, blah, blah, blah. These always cancel. That's why this doesn't show up in synthetic, because synthetic is very efficient. 0 plus 3 is 3. Negative 4 plus negative 2 is negative 6. And then the 1 comes down. X squared times what is 3x squared?
X.
No. X squared times what is 3x squared?
Oh.
3. 3 times x squared is 3x squared. 3 times 99x, 3 times 2 is 6. Change the signs. Die. Something went a little wrong with that earlier.
Yeah.
Probably, I think it's right here. I just wasn't paying attention. Yeah. You guys with me? Now, in long division, now real quick, how do I know I can't divide anymore? Because this is smaller than that, yes? That's how it works, you stop, right? Thank God we don't have like polynomial decimals. You with me? So how would I write this piece? How do you always write?
3x.
5 over x squared minus 3x.
Now, it's the integral of this shit, yes? So now I got the integral, was it negative 1 to 0? X plus 3, this piece, easy. Yeah? That piece, I gotta focus on and do the partial fraction decomposition. Partial fraction decomposition. Can you factor the bottom? Every day. That's what long division does for me. It creates a leftover remainder piece that is bottom heavy. And isn't that when I know that I can do partial fractions? This piece is nice. Look at this piece. That piece, little tears come out. That's easy. Stupid remainder is a freaking fraction, but I can do partial fractions. Yes.
So if you could factor the bottom piece, why would you do long division in the first place?
Because partial fraction decomposition only works if it's bottom heavy. And this is top heavy.
So then after you do the partial fraction decomposition over there, you have to come back and do it again for this?
No, hell no. This. All right. What does all this equal related to the problem? So I put those together. What do I get? If I put those together. What do I get? I get that. Yes. These integrals are the same. Yes. So the only piece of this integral I currently cannot do is this piece. So I'm going to do on the side, I'm going to do partial fractions for it. This piece kicks a lot of ass. Yes? Okay. Now I've focused my attention. I got the whole number part. So this is basically a mixed number, yes? Whole number piece, fractional piece. Whole number piece, nice. Fractional piece, eh. Yeah. Okay. Just like the normal numbers. Is that okay? This doesn't happen like, I don't remember how many homework problems I did like that. I don't know how many of you guys have tried any of these out, but. Anything else? Yes? Say again? Now, here's the neat thing. I was waiting until somebody to ask me, because you could factor the bottom of this, correct? It's x minus 1, x minus 2, yes? So then you can synthetically divide by 1 and then synthetically divide by 2. The trade-off is you have to understand how synthetic division interacts with the remainder piece. Does that make sense? So, I mean, you could try it and see. You could try it. So, because, go ahead. If you do synthetic division, if you do it correctly, you should get exactly the same answer we got here. Yeah. Say again?
So let's say I factor it x
Minus 2x minus 1.
if you do 1
The order doesn't matter. It's sort of like if I said divide 60 by, what, Jeff? I don't fucking know. Divide 60 by 10. If you wanted to, couldn't you divide it by 5? And then divide the result by 2? Didn't you divide by 10? Doesn't matter if I divide by 2 first and then 5? I still overall divide by 10, correct? So what he's asking is, what if I synthetically divide by x minus 1 or x minus 2 first? Doesn't matter. As long as you do both, you divide it by both. Yeah, maybe. If you have no idea what the hell we're just saying, you could just do it this way. No worries. Okay. Anything else from this stuff before we do this? Yes.
So I forget the exact equation, but it was the last one on the online homework, and I forget the exact structure of it, but I think it was like integral of x over x arctan something.
Okay. From this section?
Yeah, it was the last one on the online homework from WebAssign.
Oh, here we go. So something maybe like this, sort of. Oh. So probably have the same instructions, I would think.
Yeah.
Okay. So yeah, you start with integration by parts. I don't know if you guys remember, if I call inverse tangent u, do you guys remember the derivative of inverse tangent?
1 over x squared plus 1?
There it is. And so you're going to end up with the potential of a fraction that you have to partial fraction do. So that's what they're saying. They're saying every time we learn a new technique, it could get coupled with an earlier one. Yes? So I could start with trig sub and then it becomes a partial fraction, and it's not impossible. You understand? Yeah. Those are exciting times. Okay. All right, so what I need you to do is shake off that last quiz. Shake it off. You can make corrections. You can have the grade go up twice. Yes? Especially if you can identify a reason you didn't do as well as you wanted to. Now, there are quite a few of you guys that did pretty well, right? If you feel like you're doing everything, you're going for help, you did all the homework, you're doing everything, and you still aren't getting the grade you want, that's when we desperately, come see me anytime. But in that case, we definitely got to figure out what's going on. Very often it's like a prerequisite skill that's only cropping up every now and again, you know what I mean? And maybe I put it on the quiz a lot more and it just kind of like got in your way. I mean, you guys kind of see what I'm saying? So that's the worst situation, right? Number one, it's really bad to get a low grade. But number two, what makes it worse is if you feel like you're doing every damn thing you can. If you know you didn't, start doing those things if you can. So anything else about partial fractions before we do this thing? There are 2 problems on the quiz. And I try to make them both pretty straightforward. You're like, I don't trust your definitions, Jeff.
That was.
See if you guys can do it. I will say this. If you have trouble factoring, because you know that's the first step. Factoring the bottom, yes? Just come up and ask me, yeah, what's up?
Oh, I was gonna ask you about the problem.
Yeah, go ahead.
Number 40. I know, right? That's why I don't trust. So it's about in the class.
40?
Yeah.
Yeah. Oh, sorry. Yeah. The bottom, tell me two things about it. It's a repeated quadratic, kick ass. So how many little pieces are you gonna have with A's and B's and such? Two. One for each, one by itself, one with a square on it, correct?
Correct.
The thing that's repeated is quadratic, so what's each top gonna be in the form of? A
X.
bucket of water. No.
And X plus something.
AX plus B. You know, it's CX plus, you with me?
Oh.
The top has always gotta be 1 degree lower than what the
Yes.
true degree of the bottom is. Is that
Yes.
okay?
Good remember.
Is the, now, why is this bottom heavy? This is where I'm always a little concerned that
Oh.
changing gears gets a little weird.
Yeah.
What is the actual degree of the bottom?
4.
So this is bottom heavy, yes?
Yes.
When you start to break it apart, you consider repeats separate from actual degree, correct? That to me is the best way to memorize how to set up the form. Even though it kind of butts up against, we know it's a 4th degree, but you have to look at it a little bit differently to make the way we set it up make sense. Okay. Is that okay?
So we don't have to do any division, we just consider it.
Exactly, because the bottom, if you just step back and I just asked you what degree is the bottom, independent from partial fraction, you would say it's the 4th degree.
Yeah.
Okay. For partial fractions, it is a repeated quadratic. Okay, I like it. Hey, Mikey. No, it's bottom heavy. Bottom's 4th power. Step back. Bottom's 4th degree. Top's 3rd degree. Partial fractions. The bottom is a repeated quadratic. Yeah. Do you notice, did somebody factor the bottom for us on number 40? I want you guys to realize, yes, somebody did. Couldn't I multiply that shit out? I would get x to the 4th plus, yes? So there, it's a 4th degree. But since it's factored, I can now look at it as a repeated quadratic. So I know it's top heavy, I'm sorry, bottom heavy, I don't need to do long division. I couldn't do long division. I'd start it and I'd be done right when you started. Anything else? Okay. Deep breaths. Go over the quiz. You can make corrections. You can make corrections in this. You can make corrections in every damn thing except the final. It's very appropriately named. Now, if you want to borrow a calculator, you can. If you need it for something, I don't know. Just to kind of continue my journey into trying to get y'all to be feeling better. Every quiz is worth roughly 3% of your grade, yes? So no quiz by itself can hurt you. They can gang up on you, right? A bunch of quizzes catch you in an alley. It's not good, but you can make corrections, all that kind of business. I want to look at some problems from 7.5, unless anybody has any specific questions from anything. Just reminding you guys, 7.5 was the section that wasn't anything new. 7.5 is a section that just gives you all the different forms. Just But like I said, this is great practice for the test, because I'm just gonna give you. So, the first skill you have to have is to identify what type of interval it is. So I wanna look at a couple of the first ones, because they're kind of perfect for this. Yeah, look at these two here. I can't remember what I assigned. Oh, let me kill this light here. Yay. The little glare is gone. Okay. This guy. This was on yesterday's quiz, basically. It had some other numbers in it. It had square root, but it doesn't matter. Can anyone identify what method I should use on this? Should I use trig sub? Notice I said should. Should I use trig sub? Because what do I rule out first? U sub. Will U sub work on this?
Yeah.
Yes. Why?
Because the only thing that's missing is a constant.
True. So there is a function stuck somewhere whose derivative is in there also. Yes? You guys with me? So that is U sub. Screw all the other methods for damn sure, because they all are a little more complicated than that. Would trig sub work? Yes.
Yeah, but you don't want to do it.
Okay. Is everybody with me? Now automatically, part B is kind of funny because it's actually easier than part A. U sub doesn't work, but isn't this an integral of just, does anyone know this one?
The natural log of absolute value of 1 plus x squared.
Definitely not. So
Oh no, because it's a squared term.
really quickly. Okay. And this did happen a little bit on the first quiz. Natural log isn't the answer to anything that's on the bottom. Yes?
Right.
What's the derivative of the natural log of 1 plus x squared? 1 over 1 plus x squared times? Alright, sorry, let me write this down. What's the derivative of the natural log of 1 plus x squared? Holy crap, that's really zoomed in. What's this guy's derivative?
1 over 1 plus x squared.
And when you zoom in, my writing's even worse. So 1 over this times
2x.
2x.
Right.
We don't have an x in part B.
Okay.
But you actually can see the answer on part A is going to be 1/2 natural log of 1 plus x squared because it's missing a 2. Yeah.
That
So
one is
don't
inverse.
just make every fraction natural log of the thing on the bottom, because that's not true. It's the only power that I can use to have a natural log answer, -1 power, right? This guy, if I do U sub, the inside becomes basically 1/2 1 over U. So in terms of U, it is a -1 power. It is going to be a natural log. Okay. This guy, nope. But he's just the derivative of what?
Inverse tangent.
Inverse tangent. So this one's easier than this one because this is a direct. It's like me just saying what's the integral of sine. Yes? What about this guy?
It's another one. Which one's that?
It's not a trig, inverse trig.
Is it? Oh.
Can you factor
well
the
then
bottom?
you would. Oh right.
Can you factor the bottom?
Yeah. And then you can do. Yeah.
Partial fraction decomposition. All right. So that's why 7.5 is so perfect of a section. There's nothing new. It's just like, okay, now you know all these methods. Can you identify when to do what, right? And that's the skill you have to develop. This one very quickly, what would this be?
True.
No. I mean, sure, but no.
Would it? It could.
Yeah, I heard it. U sub, all day long, U sub. Derivative of x squared is something x. Yes? And like Sarah said earlier, I can make the number anything I want it to be. You guys? So if that was a cube, what would I want this to be?
Square.
Square, yes. I just want it to be related to the derivative of this function that's stuck. And then U sub works. You guys with me? That's how to tell if it's U sub, and that's what you always try. If it isn't just a straight up antiderivative, You say, is it u sub? Because if it is, that's easy. Relatively easy. What about this guy? No. Will u sub work here? Here's an incorrect way that students look at this. If u is x squared minus 1, I have an x, Jeff. No, you don't. No, I don't. I don't have an x anywhere in this thing.
We have a 1 over
I have a 1 over
square
x,
root.
yeah. So u sub will not work. You guys see that? I can't put x next to dx because I ain't got an x. Just ain't got. So what the hell am I going to do?
Is it inverse second?
Ooh, yeah. Yeah, and that's the one I'm not going to make you memorize, so don't worry about that one. If you don't remember the inverse secant, what do you think is going to work here? The form of it? If it's not u sub, the form. You guys kept telling me you wanted me to do certain things with these, yes? Now's the time to do it. Trig sub. If you don't remember that this is just the derivative of secant, you can do trig sub. Stop for a minute. What part of this tells me that trig sub has a chance to work? This looks like an identity, yes? Function squared minus 1. In fact, what function would I use? Something squared minus 1. Which identity does that line up with?
Sine?
Sine would be 1 minus function
Okay,
squared,
so
yes?
maybe-
1 minus cosine squared, sine squared is cosine squared. What squared minus 1 is another trig function? Secant squared. Then you see how that would eventually lead to inverse secant. Yeah. Love you guys so much. Okay, so again, I don't know, I really... If I substitute a trig function, I will end up with trig squared minus 1, and the only trig function, well, man, the one that we want to use is secant. Sine would be 1 minus sine squared. Wrong form. Tangent would be tangent squared plus 1. Wrong form, yes? So this is what I keep trying to get you to understand. You don't have to guess. It's the form of it that tells you what to substitute. And then what about C? I think their point was B would be just, it's the inverse secant, but I don't think many of us make you guys memorize the inverse trig derivatives. It's not exactly,
I don't know tangents.
yeah. But I mean, C would be another what? Okay, real quick. Would u sub work here?
No.
Don't I have an x in there? No, Jay, you have 1 over x. Beautiful. So what would I use for sure on this?
Secant? Because it's the same thing as...
It's not the same thing. No, it ain't. It's very much not the same thing. It's completely different from that. But I can still use trig sub, yes?
Yeah.
Okay. Because again, it's still a secant, yeah? Still the same form inside? Okay. So there's a lot of situations where you could use trig sub and it would work, but it would just make the work so much worse than it has to be. Okay. Okay, so let's see real quick. I want to see if there's anything else. Like these are very obviously, well,
Those you can factor.
those you can factor. Say, what would you use?
Proved.
Hoofed. Yes.
Yeah.
Partial fraction decomposition. What's up with this guy? What's up with my cuticles? That's terrible. What's up with this guy?
Can't factor. No, wait, no.
You can't factor this, can you?
Yeah.
Two positive numbers that multiply by 5 and add to be -4? Or two negative numbers that multiply by 5 and add to be negative? No, nope. Do you remember what you have to do there? Don't you have to complete the square? So it still is a
Oh.
partial fraction decomposition. It's just got a little extra work. Okay, so this section is good. What would I do for this?
Switch it to the identity.
Yeah, you have to use the power reduction, the
Which is,
1/2, 1 minus
yeah.
cosine. Okay. What about part B?
Part B where? Oh. that
Sorry,
one.
yeah, part B is the same thing.
Take out an x squared, or sine x.
All right, break this up.
Sine x squared.
Sine squared x
Sine
times
squared
sine.
x.
Okay.
And then times sine, and then just leave the sine by itself.
Now watch. This is perfect. Okay, listen, guys. We have a formula for a squared sine. I can rewrite that in terms of double angle, correct?
Mhm.
I ain't got shit for cube. So if I do write this, and I think something I still don't quite get this. you guys agree that's really all I can do of
Yeah.
any note?
Well, then you can change the sign.
What would you have to be to make this du? That's the correct way to look at this. Some of you guys were pulling a trig function next to dx, and then you weren't making u the right thing. But the minute you see what you can pull next to dx, that tells you what u has to be. Well, would I make u? So du would be roughly this. Cosine. Some of you guys are looking at this like, I ain't got no cosines in there, Jeff.
Would have to be.
Well, not yet, but I can make them show up, can't I? Can't I rewrite this as what?
1/2.
No, come on.
Oh, the other one?
I really want you guys
One
with me.
minus, one
I
minus
know
cosine
u
is
wants
one.
to be cosine x, because then du can be this. That means I need a cosine so I can actually replace it with a u.
One
Sine
minus
squared is
cosine
1 minus
squared.
cosine squared. Now I can do, this is du, and this is 1 minus u squared. Yes? Isn't that crazy? That's nifty. And the rules kind of talk about odd and even powers of sine, so it works even if there's no cosine, because you introduce a cosine right there. Okay, maybe. All right, let me erase this because it'll look weird if I turn the page. Turn the page. See if there's anything else. I just want to see if there's anything that jumps out at me before we do our little bit of new stuff tonight. I mean, look at that, dude. Not my finger was one. Look at that, dude. Like, what would you even try on this guy? You guys see the issue here? Could have used trig sub. Because x is not squared, so it wouldn't really flow with an identity, correct? So what the shit would I do? I don't know, Jeff. It's your deal, man. What would you try? So, give me something to try. Just give me something to try. No wrong answers. Well, yes, there are, but give me something valid to try. By parts? Okay, so you could try by parts. And you like 1 over x is a piece, 1 over this is a piece. Yeah? Does that sound enticing?
No.
It would actually work. You could try it. Yeah? Because 1 over x is easy to differentiate or integrate, yes? Believe it or not, 1 over this is not that bad to integrate or differentiate, yeah? So you can play around with 1 being u, 1 being v. You guys with me? Anybody have a different thing they might want to try? So I don't know if you guys are considering this and ruling it out, but what if I let u equal 4x plus 1? What would du be? 4 dx. And then I can write x is u minus 1 over 4. Right? I'm not saying this is a good way to go. I'm just saying I could do this, correct? And I tell you, it's not going to do really well. But I just want to point out you could try it. Because then this would become 1 over, x is u minus 1 over 4. And this would be u to the 1/2, yes? This is a 4, by the way. That does not look enticing. No. But it's something to try, right? Before you give up on it, something to try. Okay. All right, so it looks like by parts might be a valid way to try this. But you see what I mean? This is on a test. I'm going to be careful to not give you something that's so like not obvious that you spend forever trying every method. That would be really evil, especially on number 1. But when you're doing the homework, I need you to play around with this shit. Just, well, what seems to make sense? On number 59, why is that one easier? Looks almost the same, but now I
Because
can
you have
use,
an x squared.
so I could use,
Trig sub.
now, real quick, number 59 specifically. Can you guys see, let me erase this business. Can you guys see what I'm gonna replace? And do you guys see the issue that I don't think you've seen yet? Where's there a number that there normally isn't a number?
In front of the x squared.
So,
But you can
do you guys understand the issue? Normally I'd have a 4 here, then I would make x equal 2 times whatever the trig. What trig function am I gonna use, by the way?
tangent.
Because it's a plus, yeah? He's the only dude that's got a plus. If this was a 4, I would let x equal what? If that was what was here.
Um,
2
tangent.
tangent. Yes? But it isn't that. It's this damn thing. But now, so it's kind of like the inverse of what I just did. So I make it a 2, so when I square it, it becomes a 4 and they match. Now I'm kind of like, I want this to be a 1. Yes? So what do I square so that when I multiply before it becomes 1? 1/2. So I want x to be 1/2 tangent theta. You guys see that? You could factor a 2 out, because the square root of 4 is 2.
That's the way I would do it.
Yeah, you could do that, and then this is x squared plus.
1. Oh.
So I factored a 4 out, and then I took a square root, right? So this would be x squared plus 1/4. And then you can see it would be 1/2 tangent, yes? I love you guys. So if this was x squared plus 9, x would be what tangent?
3.
3, bam, square root of that, yes?
Yeah.
If I factor a 4 out, that becomes 1/4. Square root of that is 1/2. So if you take that number out that you're not used to being there, you can attack it the same way as always. You just get fractions, oh well, too bad. Okay. What would you rather have me throw into a problem? Fractions or complex numbers? Okay, so I'll throw some fractions. Okay. I made you guys ask for it. Okay. You're so funny, Jeff. You suck. What about, real quick, number 60. I want to show you something kind of nifty on number 60. Anybody have a clue about number 60? What can you rule out? What doesn't immediately work? Does U sub work?
Sub.
Doesn't work. The trig sub. That doesn't seem like it's gonna work. What the fudge? What do I wish that was?
2.
Yeah. So watch this. I could try to do something like. I don't think this is gonna work in this specific problem, but. And then I go let u equal x squared. That would work if the top was an x. Do you see that?
Yeah.
Okay. Does anyone else have a suggestion? Is this a fraction? Is the bottom factored?
No.
So, is the bottom factored?
Wait.
Could I multiply the bottom together?
No.
Could I multiply the bottom together?
Yes.
Therefore, it's factored. Because somebody unmultiplied it, yes? Can't I write this as a over x plus bx cubed plus cx squared plus dx plus e? Yeah. Sounds great, Jeff. Thanks, man. So, this is a collection of different forms, but every now and again they also give you a little bit of a push. Okay, it's a little bit freaky. So you gotta play. You just gotta play with it. You just gotta play with this shit. Right? And you're all like, I don't have time. Like, you signed up for it, you have time, you have to have time. Too bad. Oh. Okay. I can't remember how many problems I signed out of here, but
Probably too many.
probably too many. Yeah. If I'm ever in doubt, I assign too many. Okay, so the one thing I want to do tonight. 7.5 is nothing new. It's all the stuff from before. A couple of problems in there are, I just told you they're tricky. So if you have a lot of trouble with a few of them, you're probably fine. Some of them are kind of tricky. I want to focus on, believe it or not, I want to focus on 7.8. And then we're going to come back and do 7.7. 7.8 is still integration. 7.7. Do you guys remember? Riemann sums? I love this. I heard that in my ear over this side, and then somebody over here was like, "Yeah," like they were excited. What shape were Riemann sums all about? You have a function, and what am I breaking it up into? Rectangles. Yes. And then if I use more rectangles, I get a better approximation. So what did we do? Because we're insane, we let the number of rectangles go to
Infinity.
and that's where we got the idea of integration, yes? Did you ever wonder, even if you didn't, we're still going to do it, so don't think you can get out of it by saying, no, I never wondered that. Shit. Jeff. All right, let me borrow this. Yes. Did you ever consider Didn't I just say I wasn't gonna do this right now? Oh well. I'm doing it apparently, just a little bit. Did you ever consider that maybe instead of a rectangle, there's other shapes that would actually fit the curve better? What about a trapezoid? Wouldn't that fit the curve better? Okay, good, we're gonna do that.
Okay.
What about if I took 3 points and I fit them with a parabola? That would obviously fit the curve better because it's a freaking curve, yes? Okay. Oh shit. The one with trapezoids is called the trapezoidal rule. The one with parabolas is
Amazing.
called Simpson's rule. So I have to change it up sometimes. Give that guy props. Nobody gets credit for the trapezoidal rule apparently. All right, so that's going to be 7-7. I don't want to talk about that right now. I want to stay with integration methods, and then I'm going to go back to 7-7. So, what we're about to investigate. Let me ask you how you feel about this question.
Already horrible.
Can you guys, for that domain, can you give me a rough sketch of 1 over x squared? And this is another little skill that I think you guys just don't get enough time to play with. Especially because they almost killed pre-calc and now they didn't. Pre-calc is still alive for a couple years. They said a couple years and we're like, what's gonna happen then? They're like, you'll find out. It's like, that's a nice class you got there. It'd be terrible if something happened. Anyway. Can you guys just graph a rough sketch of 1 over x squared? I only care about the positive inputs, yes? Can you guys give me a rough sketch? If you're not sure, then when you put a 1 in, what do you get? 1. When you put a 2 in, what do you get? Yeah, so it would be this for the range of what the interval, and then it would go, at 0, it would go to infinity. So I'm going from 1 to infinity, yes? Your immediate reaction, if you think about this, I had my 5th puberty. If you think about this from a geometric standpoint, what would your immediate reaction be? What would the area of something that goes forever? What would your immediate reaction be? What would the area be of a picture where part of it never ends?
Infinity.
Okay, and you would be wrong. That's okay.
Oh.
Okay. What's interesting is, so let me say it like this. This is going to apply to something we're going to do later semester. If I added an infinite number of numbers, could the answer ever be finite?
Yes.
They're not all 0. They're positive. If I added an infinite number of positive numbers, anybody have an immediate reaction to that statement?
You would be going forever.
Huh?
You would be going forever. You would never
Yeah,
stop
so
adding
some people
numbers.
think 1 plus 2 plus 3, well that's going to go to infinity if I add that forever, right? 1 plus 1 plus 1 plus 1, do that forever, that's infinity, correct? Even 0.5 plus 0.5 plus 0.5, that's freaking going to infinity, you're slower, yes? Do it again. What about if I add these numbers?
Going to 0.
No, if I add them.
Oh.
It's at least 0.1, yes?
Yes.
In fact, what is the answer? If I add these forever. 0.1111, yes?
Yeah.
Real quick, what's 1/3 as a decimal?
3.
333. Isn't 1/3 3/9? So 3/9 equals 0.333. So what's 1/9? Divide by 3. 1/9 is 0.11111. So the answer to that is 1/9.
Okay.
So integration is adding, correct? If what I'm adding gets small fast enough, then the answer could be finite. Let me say this again, because this is a huge idea for this class. Chapter 11, not favors. It's going to be, chapter 11 is going to be sequences and series. And what I just said is a huge backdrop to that. If I'm adding an infinite number of things, which is what an interval adds stuff, as long as every element's getting smaller fast enough, it could come out finite, correct? So if I do 1 plus 0.9 plus 0.8 plus 0.7, that's not getting smaller fast enough. You guys don't know that yet, but we'll prove that later. That one is definitely, every time I go, isn't it divided by 10?
Yep.
So that one's getting smaller fast enough. It kind of, what I say is it gets out of its own way. Every new element just adds to the next decimal place, so that leaves room. So, I guess, semi with me? So I'm laying some groundwork for later because it has to do with these problems. This will come out to be a finite number. So let's try it. What do you think I have to be careful about? What do I do when I integrate? After I integrate, don't I plug these in? Are you allowed to plug infinity in?
No.
No, hell no, never. Don't you be telling me infinity squared. That's bullshit. So what do I have to use? What method, if I have something going to infinity, and that word going to gives
Oh
it
my
away,
God.
I have to use a limit.
No. Sorry. Did you say that out loud? Sorry.
Or we could do complex analysis.
No.
No, sorry. I'm gonna pull it every time. I don't want to do it. We can do complex. Okay, let's do limits. So, here's how I rewrite this integral. So this integral is pretending like everything's fine. Like I just plug t in. What can I not plug in? I can't plug in infinity. Does t ever actually get to infinity?
No.
Because that's the whole idea of a limit, correct? So I'm allowed to plug t in. All right, do it. I'll wait. By the way, this is called an improper integral.
Oh, yeah.
Poor little dude. Improper integral does not mean it doesn't have an answer. It just means that one or both of its limits goes to some kind of infinity. So this integral is pretty straightforward, yes. You just kind of let go of the weirdness over here. That integral's easy. What is that integral? Please don't tell me natural log of x squared. X to the negative 2, integrate it. What do you get? X to the negative 2.
Negative x to the negative 1.
Yes, and I wanted that, and I don't want to lose my limit. And I want to evaluate that from 1 to t. Is that cool? So this is just integration with a limit dude in front. So you don't care about the limit until the end, right? And you're going to be writing the limit. You're going to be writing it. You have to identify. You have to replace infinities with t or a or whatever, something. But you're not going to worry about it to the end. So the middle is going to be a normal integral problem. That's why I kind of like to do 7-8 before 7-7, because this is just more integrals. What kind of integrals will you have to do? Any? Ha ha ha. Sorry. So I get the limit as t goes to infinity of, plug a t in, you write it like this, is that cool? This is 1 over x, yeah? Minus, so minus and negative is plus, plug a 1 in, yes? Is that cool? And then let t go to infinity, and what's the first piece go to? What's the first piece go to? What's this go to if I let t go to infinity? 0. So what do I get? 1. Funky. It feels off about that, but I'll be alright. Let me think about it for a second. I can't see it. Something feels off, but we're gonna be okay. Now, if I do this, I'll look at that later. If I do this, I've just changed one thing about it, right? So if I have 1 over x squared, that's 1 over 4, 1 over 9. Yes, it's all the squares in the bottom. This is 1, 1/2, 1/3. Do you see how it's getting smaller, slower? Does it make sense when I say that? It's getting smaller, slower. So when I integrate this, it might end up not having a finite answer. So let's do this one. This was nice and quick. Because what's the integral of 1 over x?
Natural log of absolute value.
Natural log of x. Oh, let me rewrite this first. Blah, 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 blah. So you get the limit as t goes to infinity, natural log of x from 1 to t. That's gonna bug me. No, I think it's okay. That's right, okay. So the limit as t goes to infinity. Is everybody cool with that? You guys with me? Now I'm just gonna plug shit in. Natural log of t minus natural log of 1. What's the natural log of 1? 0. And what happens if I let t go to infinity? What does natural log do?
Goes to.
It goes really slowly, but it does go towards infinity, yes. The slope is always positive. So, did this integral have a finite answer? No. You guys doing okay? So this is bringing back the idea of limits. We're merging it with the idea of an integral. Let me give you, let's do one more example. Something a little bit freaky. Yeah, let's try, wait a minute. Oh, I'm looking at the wrong section, that was weird. Yeah, let's do this one. I like it. Yeah, let's do that one. All right, let me write it down. Oh, Jesus, I can't see shit. Number 8. What was that? 1 to infinity. 1/3 to the x. So the first thing you have to do to make it all official, do not skip this step. We can't skip this step. How do I rewrite this immediately?
The limit as t goes to infinity of.
Now, can you guys see how I can rewrite the inside if you want to? Instead of 1/3, I can write this as 3 to the negative x. It's up to you. I would do that. And this is one of those derivative rules that students forget because we don't see it that often, but we're anti-differentiating something that we might have forgotten how to even take the derivative of in the first place. What's the derivative of a to the x? A to the x, natural log of a, which is explaining why e to the x is its own derivative, because natural log of e is 1. Okay. E is that special little number that doesn't need an adjustment. It matches perfectly with itself. The slope of it is the same as it. That she'll meet. Everybody else needs a little a natural log adjustment. Sounds like a chiropractor. So how do I integrate? So if derivatives multiply by natural log of the base, and you gotta worry about the negative x too, right? Oh shit. How do I integrate this thing? No. So real quick, if the derivative of a to the x is a to the x natural log of a, what's the integral of a to the x? Yes! Just the opposite shit. Yes? So this would be 3 to the negative x divided by. We have one more thing to take care of because this derivative would have a negative pop out, yes? You guys semi with me? Maybe? Okay. And now I just gotta plug stuff in. So I can rewrite this a little bit, yes? Since I have to evaluate limits, it's a little bit easier to write this as a true ratio, get rid of all your negative powers, right? When I plug a 1 in, I just get 1/3 ln 3, yes? If I let t go to infinity, what does this piece do? It goes to 0 because the bottom gets stupid big. So the answer is actually this. Now, real quick, looking back at the original, if I consider 1/3, if I consider just the whole number parts, what's 1/3 to the first power? 1/3. 1/3 squared is 1/9. So it goes 1/3, 1/9, 1/27, 1/81. That's getting out of its own way even quicker than the 0.1 blah 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 did. Yeah? Or at least in the same order. So that's why it kind of makes sense that it does have a finite answer. It gets out of its own way. It doesn't add up to infinity. It's the same thing that 0.1 plus 0.01 did. Do you have to understand what I just said? No, because you could just do the problem, get the answer, and move on. Yes? But we're going to see stuff like this later this semester in a different way when we start talking about sequences and series. Okay. Yeah. Let's leave. Let's go. That's enough. We're doing great. So next week, we're going to finish up this first thing on Tuesday. And then probably Thursday will be devoted to 7-7. I might get into it a little bit on Tuesday. So that's the upgraded Riemann sum approach. All right, get out of here. Go. I'll see you guys.
Are we doing 7?
7-6 is not in our curriculum.
Oh.
If you look at their homework sheet, it's not there.